How do you convert between degrees and radians? Good question. The big key is to remember how many radians are in a circle. And we talked about this. We marked radians all the way around the circle, and we noticed, well, here was one radius length, and we marked one radius length around the circle, and there was one radius length. Then we marked another radius length, and we marked another radius length. We had all these radius lengths marked around the circle, and we came up just a little bit short. It was about 6, but a little more than 6. And then someone had the bright idea, I bet it's 6.28 because that's 2 pi. So we recognized then this must be 3.14. That's pi radians. So if we know there's 2 pi radians in 360 degrees and pi radians in 180 degrees, then we have a really good ratio that we can work with. So I'm going to use this as my big idea. Pi is equal to 180. So how do we find special angles? Well, we're especially interested in things like 30 and 45 and 60 and 90 and some of those angles. So let's start with 90. 180 divided by 2 equals 90. So that also must equal pi over 2, because if I divide 180 by 2, I also need to divide pi by 2. So there's another important relationship. If I wanted to divide 180 by 3, I would get 60. So 60 is equal to pi over 3. If I divide 180 by 4, well, off the top of your head you might not know that, but if you think about 180 divided by 2 is 90, and if you divide it by 2 again, it would be 45. So this is 45, and so that it has to be pi over 4 because it has to be pi over 180. Pi equals 180, so I divide them both by 4 and I get another ratio that is a true statement. 45 is pi over 4. And if I take 180 divided by 6, I get 30, and so 30 must be pi over 6. These are really important ones to remember where these are, to remember that these ratios right here. If you can remember these, then you can figure out any of the other angles you need to find, because all of the other special angles are multiples of these angles. So for example, if I wanted to know what is 3 pi over 2 in degrees, 3 pi over 2 is 3 times pi over 2, which is 3 times 90, which is 270. So 3 pi over 2 is 270. Or maybe I want to find 300. 300 is equal to 5 times 60, which is 5 times pi over 3, so that's 5 pi over 3. Okay, so I can use those ratios back and forth to figure out some of the special angles. Let's just practice a few more. What if I wanted to do, let's say, the 45s I think are a little trickier because you don't recognize them as well. So let's say I wanted to figure out what 5 pi over 4 was. And I could think, well, that's not that bad. I could do 5 times 45 like that, because pi over 4 is 45, and figure out 5 times 45. That would be a 90, 2 90s and an extra 45. So 180 plus 45 is 225. So here's what I'm thinking in my head when I see 5 times 45 is 45 plus 45 plus 45 plus 45 plus 45. And I recognize that's a 90, another 90 plus a 45. So in my head, that's kind of what I'm doing. And I'm telling you this because I'm not going to be allowing you to use a calculator on this, so you have to be able to think of these numbers in terms of things that you can do in your head or things that you can multiply on paper easily. Now what if I said 315 is equal to how many radians? And I just realized there's something important I probably should go over with you to help you remember, is that all of our angles that have the same reference angle have the same fraction of pi. So let's before I do 315, let's do that quickly. Okay, so if I have a 30-degree reference angle, these are all 30-degree reference angles. Well, 30 we already said was pi over 6. Actually, I'm going to start with the 45s because I think that's easier. So here's my 45 degree. Sorry for making you erase your notes. 45 pi over 4. Now, if I went another 45 degrees, that would be 2 pi over 4. But 2 pi over 4 here is pi over 2. We already know that's 90. And so when I get to over here, this is going to be 3 pi over 4. And that has a 45-degree angle. So this is my 45 degrees, and this is my 135 degrees over here. Then when I get to here, it's going to be 4 pi over 4, but that's just pi. That's 180. So my next one is going to be 5 pi over 4. This also has a 45-degree reference angle. This is my angle 225. And then this would be 6 pi over 4, but that's the same as 3 pi over 2. So this one's going to be 7 pi over 4, and that's a 45-degree angle here. And so this is going to be my angle 315. So notice that if it's a 45-degree reference angle, the 45, 135, 225, and 315, then they're always going to be some fraction of with pi over 4. And notice there's the even ones reduced down to a different fraction or a whole number. So it's all the odd pi over 4s. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So 315 is 7 pi over 4. If we look at the 30s and the 60s, here's 30, which is pi over 6. 60 is another 30, so it's 2 pi over 6, but that's pi over 3. So 60, that's 60, and this is 30. Then if we go another 30, that's 3 pi over 6, but that's pi over 2, so that's 90. And then we go another 30, and that's 4 pi over 6, but that's 2 pi over 3. And 2 pi over 3 makes sense because this is 120, so here's my 90. This is 120, and 120 is 2 times 60. So 2 times pi over 3, 2 times 60. If I go another 30 degrees, then I'm at 150, or I'm at 5 pi over 6. 5 pi over 6, 150. 6 pi over 6 would be just pi. So when I go to another 30 degrees, and that's 180, so this would be 210, or 7 pi over 6, 210. Another way of looking at 7 pi over 6, and I should probably write that a little more neatly, is that it's 7 times pi over 6. Well, 7 pi over 6 is 30. 7 times 30 is 210, because 7 times 3 is 21. So there's another way to look at it. Then I would get to 8 pi over 6, which reduces to 4 pi over 3, and that's my 240 degree. Then I get to 9 pi over 6, which is 3 pi over 2, and we already know that's 270. If I go another 30 degrees, I'm at 300, and now I'm at 10 pi over 6, or 5 pi over 3, that's 300. And the last one now, I've gone one more pi over 6, I'm at 11 pi over 6, that's 330, that's 11 times 30. Okay, so if I look at these in different colors here, I'm going to do all the 30 degree ones. Pi over 6 is 30. 5 pi over 6 is 150. 7 pi over 6 is 210. 11 pi over 6 is 330. All of those have 30 degree reference angles. 30, 30, 30. Notice they are all powers of 6, are all fractions of 6. This is pi over 6 less than pi. This is pi over 6 more than pi. If we go all the way around to 2 pi, probably ought to write that one in, 2 pi is 12 pi over 6. So 11 pi over 6 is just 1 less than that. Now if we look at the 60-degree reference angles, I'll do those in blue. We have pi over 3 equals 60. We have 2 pi over 3 equals 120. We have 4 pi over 3 equals 240. And we have 5 pi over 3 equals 300. So notice anything with a 60-degree reference angle always has a pi over 3 in it. Anything with a 30-degree reference angle always has a pi over 6 in it. Then the pi and the pi over 2's are at 0, 90, 180, and 270. Obviously this is 180 here. I want to make that color fit with my pattern here. That's 180. Okay. So remembering the pattern, remembering fractions of pi, remembering to looking at multiples of things. So let's look at another one. 240 is equal to 4 times 60. I know what 60 is, at least that's what you need to know. 60 is pi over 3 because 180 is pi. So 1/3 of 180 is 60. This is pi over 3, so 4 pi over 3. Now, what if you don't think that way really well? What's another way to think of this? I could say 180 is to pi as 240 is to x. So I can say 180x is equal to 240 pi. And so x is equal to 240 degrees times pi over 180 degrees. Now I don't like this one as well because I have to do some work reducing the fraction. The degrees cancel out. I divide these both by 10 and I would get 24 over 18. Well, 6 goes into 24 4 times. So this would be 4 pi. 6 goes into 18 3 times. So that's 4 pi over 3. I honestly think that's more work though than just remembering that 60 is pi over 3 and 240 is 4 times 60. But you can do it either way. Let's go the other direction. Let's say I have 11 pi over 6 and I want to know how many degrees that is. So I'll show you a couple ways to do that. First of all, I could think it's 11 times pi over 6 and remember that pi over 6 is 30 degrees. So it'd be 11 times 30, which is 330 degrees. Another thing I can think of is, wow, that's just, pi is the same as 180. So I can just say that's 11 times 180 all over 6. Well, 180 over 6 is 30, so I get down to 11 over 30 again, which is 330. I would say those are probably, then I could also do the ratio method. I could say, well, the ratio method would be a little trickier here. I'd say I'd stick to one of these two in this instance. So those are some ways to do conversions. Once you know what 180 is, it's easy to remember to divide it in half to get 90, and then if I want 270, it's 3 times 90 is 3 pi over 2, which we did already. So I think those are pretty good for converting back and forth. Now, what if it's not a special angle? You'd obviously have to have a calculator. So if it's not a special angle, you're going to use a calculator, or you're going to have some kind of a weird fraction of pi, which is possible. You could do that. But let's say I wanted to say the number of degrees in 1 radian, which is kind of a good thing to know. The number of degrees in 1 radian. So I could say pi over 180 degrees is equal to 1 radian over x degrees. So I would say pi x equals 180 times 1, or x equals 180 divided by pi, which turns out to be, if you do that on your calculator, about 57.3 degrees. So you can always use the ratio method if it's not a special angle. So let me do another one. Let's say we want to convert 218 degrees to radians. So I would say pi over 180 is equal to x over 218. So I always I've got radians over degrees on the left-hand side, so I have to have radians over degrees on the right-hand side. So I'd say pi times 218 divided by 180 equals x. And like I said, I could make that a really weird fraction of pi, but it would make more sense here to say pi, using my pi button here, times 218 divided by 180. Did a control enter, that gives me 3.8 radians. And let's just think about that, 3.8 radians. So if I were to draw 218 degrees, that's very sloppy. And by the way, radians is a unitless measure, but sometimes it's helpful to put a little r there just to remember we are in radians. So if we think about 218 degrees, here's 180. 218 degrees is probably around here somewhere. And let's think when we labeled our radians around the circle, this was 1 radian, 2, it's a little too high up for 1 radian. 1 radian is about 57 degrees. 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. So 3.8 radians, that looks pretty reasonable. I probably didn't draw that very accurately, but I know it's in between 3 and 4. I know it's more than 3.14, so it has to be a quadrant 3 angle. So being able to recognize when your answer is reasonable is important too. I probably could tell you a lot more about radians, but I think I'll stop there. That gives you a good idea of converting back and forth between radians and degrees.